Hello, College Algebra. Welcome to week 6. I know a lot of you guys are going really strong and doing everything you can to make it through. I wanted to give you a couple hints on Chapter 10 homework. So the interval is going to be the numbers that fall between. So here, this interval starts at 10 and goes up to 19 and 99 hundredths. If you look at the data set up here, there's 0 numbers that fall in between. The frequency is basically going to be your count. So then I go to the next one, 20 to 29 and 99 hundredths. I have 1, 2, 3, 4, 5, 6. So that's why I put 6 as my frequency because that's the count. That's how many fall between. And then when I come down, what they're looking for is they're looking for me to be able to make a histogram to represent the data. Across the bottom is going to be my intervals. On the left is going to be the frequency. So intervals, the x-axis, frequency is my y-axis. And what I'm going to do is I'm going to say, okay, from 10 to 20, I have 0. So all the graphs represent 0 at that point. But from 20 to 30, I have 6. This graph right here represents 2, so he can't be right. This graph represents 6, so he might work. This one represents 4, so he cannot be right. And this guy right here represents 6, so now it's either B or D. I go from 30 to 40, I need 2. Well, this guy's at 5, he can't be right. And this guy is at 2, so D is my correct answer. And then as I go, the frequency polygon, what that's looking for is it's going to do the midpoint. So you see how it goes from midpoint to midpoint to midpoint. But it has to be the same exact graph from the second point. So this is the same graph, and he's going from midpoint to midpoint. And that is how that question works. For my stem leaf plots, what this is representing how the data looks, but you're only using 2 of the digits. You always want to look down here at the units. The units say 3/2 equals 3.2. So what I'm going to look for here is this 0 is going to represent anyone who starts with a 0 decimal point on up here. The leaves have to go in numerical order. So I need to represent 3/10, 7/10, 1/10, 9/10, 1/10, 2/10, 6/10, 6/10, 5/10, 3/10, and 5/10 again. And what I have to make sure is that everyone is represented. So see how I have 1/10 and I have 1/10? That's why I have 2 1s here. And with my 0 as the stem, I have 2 1s for my leaves because I have 2 1/10s here. I have 1 2/10, so that's where this 2 comes from. I have 1 2 3/10. That's why I have 1 2 3/10 down here. I have 1 2 5/10. That's why I have 2 5/10 down here. I also have 1 2 6/10. 1 2 6s here, 1 7/10, and 1 9/10. And you're going to do that all the way through. I have 8 here because you see I have 8 and 7/10, 8, and then I have the 7 on the 10th side. I have nothing with the 6 and the 7 because I have nothing that starts with a 6 or a 7 in my data set. Remember, you can always use the copy to clipboard or open in Excel, and then you can sort the data to make it a little bit easier. When they ask you to figure out what kind of graph it's going to be, a distribution, this is going to be a uniform distribution. It's uniform all the way throughout. It's like a straight line. A normal distribution would have been if it was a bell curve. And so a bell curve, it looks like a bell, and it's going to be symmetric. If it's right skewed, what that means is the data would have been smaller on the right. And then a left skewed, the data is smaller on the left. So here's a good example of being right skewed. You see how there's a little bit going on over here, but for the most part, you got the data high here and low here. Low on the right, smaller on the right means it's skewed on the right. Skewed and smaller both start with S. When you get into 10-2, what it's looking for here is it's looking for the mean. All the mean is the average. add them all up, divide by the number you have. So here I would add them all and I would divide by 1, 2, 3, 4, 5, 6, 7, 8 because I have 8 points of data. So for something like this, they're telling me I have a value 0, the frequency, remember frequency is the count 4 times. So to calculate this, I would have to multiply 0 times 4. I would add that to 1 times 2 because the 1 value occurs twice. I would multiply 12 times 5 because the value of 12 occurs 5 times. And then I would add to that 4 times 2, 14 times 2 because 14 occurs 2 times. I would then have to divide that by the total number of data points, 4 plus 2 plus 5 plus 2. So that's going to be 13. To find the median of the data point, remember the median happens in the middle. Think about the median of the highway. If you're driving down the highway, it's the median is right in the middle. You always, always, always have to order your data from smallest to greatest, and it's going to be the one that happens exactly in the middle. This particular data set is an odd data set, so I would have 3 on the left and 3 on the right, and it would be my 4th data point if I had these 7 after I ordered them from smallest to greatest. If I had an even number of data points, I would average the 2 middle data points. That means I add the 2 together and divide by 2 because I'm only averaging those 2. The mode is who happens the most. MO starts with mode and most. And so what I'm going to do is I'm going to count all my data points and see who happens the most. Note you can have no mode. So if everyone only happens once, there's no mode. But you can also have more than one mode. So if you have multiple numbers that occur multiple times and it's the same number, so if 2 numbers occurred twice or 2 numbers occurred 3 times, they would both be the mode. Here, 24 occurs twice, everyone else happened once, so there's only one mode of 24. Okay, so I now wanted to show you a little bit on how to find the range and the standard deviation. The range is going to be your maximum minus your minimum. Maximum is going to be your biggest. This guy's already in order, so my maximum is 188. My minimum is 110. So 188 minus 110 equals 78. To calculate the standard deviation, I want to show you how I jump into Excel to do this one. So what I do is I put up, you can write these out as well. But just make sure if you write them out, you're using lined paper and you're keeping everybody straight. So my data here, I have 110, 126, 129, 148, 150, 157, and 188. I write all my data down the first column. I then calculate my mean and I write that straight down the second column. My third column, I'm going to subtract my data minus my mean. So 110 minus 144 equals negative 34. I then do that for the next data point. 126 minus 144, that's a negative 18. I do that all the way down to the last one, 188 minus 144, that's 44. I then need to square that column, each individual piece. Negative 34 times negative 34 equals 1,156. Negative 18 times negative 18 equals 324. All the way down to 44 times 44 equals 1,936. I then add all of these numbers. When I add all those numbers, I get 3,862. I then need to divide by n minus 1. This is a sample standard deviation. I have 1, 2, 3, 4, 5, 6, 7 total data points. So n minus 1 means I need to divide by 6. I then need to take the square root of that number in order to get the standard deviation. This first number here is called the variance. Once I take the square root of it, then it's the standard deviation. I hope that helps a little. When you get to a piece like this, what you want to make sure is that you're going to be using that midpoint of the interval in order to determine once you start getting your mean and your standard deviation. Because it's the interval, you don't know how many of each you have. You have 10 in the interval between 0 and 29. So what you're going to do is you're going to use the midpoint of that interval from 0 to 29 to ensure that you're on average. So these numbers are going to be a lot more of an estimate. And then when you get to the last section, what's going to happen is we're going to start calculating z's. With the z's, what's going to be true is the z-score is going to standardize your standard deviation. And so what's going to happen is you're going to take your value minus your mean and divide that by your standard deviation. The z-score is found as x minus mu divided by the standard deviation. So what I want to point out here is the percentage of the area found under a normal curve between the mean and the given number. Your first page here, so you're going to have two pages. This guy, all your values are going to be positive. And so you see how they're asking about 1.7? I'm going to go all the way in the chart until I find 1.70, 0.4554. They want it as a percentage. Move my decimal point 2 to the right, 45.54%. The other thing I want to show you is the other page here is going to be the higher values here. And so if you had a negative value, it's a symmetric curve, so it's going to be exactly the same. So you sometimes will need both tables. So here, since it is a normal distribution, it's symmetric, when they look for negative 0.39, I need to come here to the 3.9, 15.17%. 0.1517, decimal goes 2 to the right, 15.17%. So for this one, what's going to happen is you can look up between the mean and 1.43. You can also look up between the mean and 2.82. So what we have to do here is we're going to have to look up both z equals 1.43 and 2.82. So if I do that, 1.43 is going to get me 0.4236. And if I look up 2.82, that's going to get me 0.4976. What I'm then going to do is I'm going to put them in my calculator, and when I do the subtraction, I'm going to get 0.074 because I need to subtract the larger from the smaller. You're never going to end up with a negative percent here. You're going to go 2 to the right, and that's going to get you 7.4%. And so that's how you do those. Be really careful though, because if one is negative and the other is positive, what that means is one is falling to the left of the mean, the negative, and the positive is falling to the right of the mean. So when you look up the two values there, you have to make sure that you add them together as opposed to subtracting, because you're really minusing a negative. So for this one, remember using the z-table. Remember what the z-table told us. Back in question 1, we talked about the z, to calculate a z, the value minus the mean divided by the standard deviation. So on this one, what we have is, according to a label, a can of soup holds an average of 308 grams and a standard deviation of 4.3 grams. Assuming a normal distribution, what is the probability the can be sold can hold more than 309? Because of those words, more than. 309 is my x, 308 is my mean, 4.3 is my grams. So I'm going to take my 309 and subtract 308. That's going to get me 1. And then I'm going to divide that by 4.7. That's going to get me 0.2127. What I then need to do is look that up in my table. If I look up 0.21 in my table, what I'm going to get is 0.0832. Remember, that's the area between the mean and 0.21. They want the area to the left of 0.21. Since this is half of the table, I then need to do what? 0.5, 50% of the table, minus the value I looked up of 0.0832. That's going to get me 0.4168. And just as you found, they changed the values on you. And so here is my question. The 304 minus 303 was 1. 1 divided by 4.7. And then I looked him up, 0.4168. So that was, if I change these, 304 and 303. So sometimes they change them on me too. It's pretty good for me to leave this in here just so you guys see that. So 304 minus 303 is 1, divided by my 4.7, 0.212. I only look up the 0.21. When I look up that 0.21 in the table, I get that 0.0832. I do the 0.5 minus, and I get 0.4168. All right, guys, good luck this week. You guys can do this. It's the last week. Strongly, strongly, strongly recommended. Practice Math 112 cumulative final exam. It's a quiz, so one thing you can do is, if you do go through that quiz, answer one question, submit it, then you can look at the answers, go right through, study that. That would be your directed piece in order to study for that Math 112 cumulative final exam. I'll talk to you guys soon. I'm sure I'll talk to you through the week. Good luck. I know this was a long video. I hope it was helpful. Have a great day.